We're going to keep going with section 6.7, which is our inverse relation and function section. And I'm just going to shorten it as inverses right now. We're going to look at a couple of things related to this function, f of x equals the square root of x minus 2. And as of right now, we don't really know what that looks like. We'll see what this function looks like in our next section, section 8. But for now, just keep in mind that this is a function because if we plug in value for x, since that radical is already there, we're just going to get one y value. So we have a function here, all right? We'll end up seeing in our next section that this shape, square root of x minus 2, looks like this. So you might think of it as half of a parabola. All right. So either looking at this little graph, which in theory you don't know what this looks like yet, or even more so looking at the equation, let's think about what our domain would be. So think about what kind of x values could you plug in to this equation and end up with a real number. If we plugged in a negative number, for example, a negative minus 2, we're having imaginary. A square root of a negative number is imaginary. If I plugged in 0, 0 minus 2 is negative 2, square root, that's imaginary too. So the smallest number that I could plug in for x here is really 2, which gives me my domain. X is greater than or equal to 2. The range can be kind of tricky to figure out, and I honestly think the easiest way to find my range is to look at what my domain value is. So I'm saying my x values have to be more than 2. If I plug in 2, what's my y value? 2 minus 2 is 0, square root of 0 is 0. Okay, so I know my y value is related to 0 somehow. And then think about, okay, are my y values going to be more than 2? Or more than 0? Sorry. Are my y values more than 0 or less than 0? Let's plug in 3 for x. 3 minus 2 is 1. Square rooted is 1. 1 is more than 0. So my range is y greater than or equal to 0. Okay, this next part really brings me to the same idea that we were dealing with in your last videos that you watched. The main idea with inverses is that your x and your y switch. So the same thing happened with our domain and our range. So remember, domain is your x values, range is your y values. That tells us that the domain of our inverse if our x and our y switch, these guys switch, what was my range becomes my domain. Since domain is talking about x's, the domain of my inverse is x greater than or equal to 0. And then the range of my inverse, again, x and our y switch, what was my domain is now my range. Y is greater than or equal to 2. All right, so this is kind of something to keep in mind when we go into our next part, where we want to find the inverse function. And f of x equals the square root of x minus 2. I'm just going to rewrite that down here as y equals the square root of x minus 2. So if you remember what we were doing is we switch our x and our y around, literally switch their places, and then we want to get y by itself. So the first thing we'd have to do, square both sides to get rid of the square root, and then add 2. Okay, here's kind of the new thing compared to what we had been doing in section 7 so far. We would say this is my inverse, that's it. Okay, but think about what this is going to look like. If you look at the domain of this, if we just look at x squared plus 2 as my function, there's no value for x that you couldn't plug in. Just looking at this part, my domain would be all real numbers. But based on what we found out up here, by switching my x and my y around, my domain of my inverse is really just x is greater than or equal to 0. So I need to specify that down here. So my inverse is still y equals x squared plus 2, but we only care about when x is greater than or equal to 0. Okay, and then the reason this kind of works is because think about if this is what my graph looks like, and I'm saying that my x and my y switch, if I switch my x and my y around, that's going to give me this part. That's not going to give me the rest of my parabola over here. It's only going to give me these points, this right side of the parabola. All right. I'll do one more example that is like that, I guess, next up. So I really should have said up here that this is example 4A.